Okay. So you know that your Unit 2 test is next week. You can take it on Monday or Tuesday or Wednesday. I sent everybody the link, both classes, I think maybe Wednesday or Thursday of last week. So most of you have already signed up for a test, but if you haven't done that, do so as soon as possible. For my Monday, Wednesday class, they will meet on Monday, but not on Wednesday. Wednesday is the day that class will be off, so that they could potentially take their test during that time. But for my Tuesday, Thursday class, per fall break, y'all would have only met on Tuesday of next week because Thursday is fall break. So you don't have class on Tuesday so that you could take the test during that time. So for my Tuesday, Thursday class, you guys wouldn't meet anyway next week at all. But Monday, Wednesday, we'll meet on Monday, not Wednesday. Okay, so let's talk about the Unit 2 test. Now, procedurally, it's the same thing. So you sign up for a test time, you show up at the math lab during that test time, and that's when you take your test. And just like last time, you should have the following. So you want to make sure you have your student ID, your pencil, your TI-30 XII calculator, and believe it or not, your phone. Now remember, your phone is just for the two-step verification part to get into the computer. Then you would turn it off and of course take your test. As always, make sure that in maybe today or tomorrow, if you're in the math lab, or hopefully you've already done this week, but definitely try to log into the computers that are in there. Make sure they're working for you, just so that doesn't hold you up on test day. But that's what you want to bring to your test. Okay. Every question comes from the Unit 2 practice problems, just like the Unit 1 practice problems, Unit 1 test. Every single one of the questions comes from that assignment entitled Unit 2 practice problems. So as always, you want to make sure you do the whole thing to 100%, because it is worth a homework grade, but you do have to get a 70 or higher on it in order to get partial credit on the actual test. Question? Yes. So the test is made up of 16 questions. Okay, and you have 70 minutes. And I will tell you that only one of the questions is one of those like long 9-part ones. Okay. So used to be more than that, but it was just taking students too much time. So we reduced the entire test to 16 questions, and only one of them is the super long one. But every single one of those 16 come from the review somewhere. Okay. So any like logistical questions about the test or anything like that? Like how many questions, you know how many questions, how much time, you know what to bring, you know where to sign up. Everybody's good with all that stuff? Okay, so let's jump into looking at ALEKS. I picked out before class some questions that I wanted to do with you. So we're gonna do 1 and 2 to practice these kind of long ones, okay? Now, the only unfortunate part about writing like on top of your ALEKS assignment is that it's gonna make me erase it as I go because it doesn't like keep it where I put it, if that makes sense. So just make sure you're writing with me as I go. But Tuesday, Thursday class, you guys, like I said, I'm gonna send you this recording as well. So if you miss something, you can always go back and watch the recording. Okay, so it says, consider the given function p of x equals 3 times x minus 3 squared minus 12. Now I'm working these with you. This is not something I worked before class. Chose them before class, but it generates new numbers every time I open it up. So y'all do this with me. Don't let me put something in my calculator wrong, like that kind of thing. So this is definitely in vertex form. So I do want you to know vertex form for your test, which would be p of x equals, or f of x or whatever of x, a times x minus h squared plus k. So remember, the vertex is hk, where we keep the sign, change the sign of h, keep the sign of k. Okay, so first question though, now that we've kind of looked at that, let's go to the first question. First question says, determine whether the graph of the parabola opens upward or downward. So that's a positive A value. So does it open up or down? Yep. Oh, upward. Check. Okay. Identify the vertex. So we said the vertex is HK. Change the sign of H, keep the sign of K. So 3, -12. And if I do something and you're like, I don't know where she got that, please stop me. I'm happy to help you with whatever. Any questions? Okay. All right, C. Determine the x-intercepts. Enter your answer as an ordered pair. Okay, so remember, x-intercepts are found. Let's see. I'm gonna have to move this camera just a little bit. There we go. Okay, x-intercepts are found when we let y equal 0. So that means we set the function equal to 0. 3 times x minus 3 squared minus 12 equals 0. So first thing I would do is add 12 to both sides. 3 times x minus 3 squared equals 12. And what would you guys do next? Divide both sides by 3. Okay, so x minus 3 squared equals 4. This will be nice because what's the next step? Square root both sides, just put a plus or minus in front of the numerical side. But remember, when you square root both sides, the square root symbol and the square cancel each other out. So we have x minus 3 equals plus or minus 2 because the square root of 4 is 2. So that means we really have two equations. X minus 3 equals -2 and x minus 3 equals +2. So if we add 3 to both sides on the first one, -2 plus 3 is 1. Add 3 to both sides on the second one, x equals 5. Okay, but I'm pretty sure they ask for them as coordinate points. Let's scroll down and look at the actual problem. It just says, enter your answer, as an ordered pair. So that's the same thing as coordinate points. So we would say 1, 0 in a set of parentheses, and then you'd have to do a comma and another set of parentheses, 5, 0. All good? No questions? If you ask something, like I said, the mic's not going to pick it up, but I'll repeat the question so that it's saved on the video. Okay, so we're good to there. Let's see what it's asking us for next. Y-intercept, that makes sense. Okay, y-intercept is where we let x equal 0 or plug in 0. So y equals 3 times 0 minus 3 squared minus 12. So let's see, 0 minus 3 is -3. And -3 squared is 9. And 9 times 3 is 27. So that's 27 minus 12, which is 15. So probably a coordinate point again, I would imagine. So 0, 15. But let's go see how they want it. Yep, enter your answer as an ordered pair. Okay, that means coordinate point. Okay, all good with that? All right, coming right on back. We are now, oh, I needed the eraser and I chose the pen. Come on. There we go. Okay, we're now on E. So they're asking us to sketch the function. I'm gonna have to come down here and do that. Okay, so it just says sketch the function. So it doesn't tell me how many points to use. So I'm just gonna use the points that I found, vertex, the 2 x-intercepts and the y-intercept. Now, if you wanna actually try to click on those points, you totally can. That's completely up to you. I think I like to put the points in because then there's no guesswork. I can just put in what I already know is right. That's just my preference, but honestly, I think it makes it so much easier. Now, y'all have this on your paper, but it doesn't want me to scroll up. Can somebody tell me what the vertex was?
3, -12.
Okay, so I do 3, -12, and then I tell it to plot the point. Okay, and then I had what, 1, 0, and 5, 0? Okay, so 1, 0, plot the point. 5, 0, plot the point. And really, that's all you need. In fact, I think you only need 2 points, but if I graph it and it goes through all of these points, then I know I did everything right, correct? And I think that's particularly important when it comes to the test, because here's the thing. In the homework, it's like put in part 1. Oh, it's right. Good job. Put in part 2. Oh, that's right. Good job. So by the time you get to part 5 where you're sketching it, you already know that all of your points are correct. That's not how the test is. It's going to be all of them up there. So if I were you, I would put in all the points that you found and then do the sketch or whatever. And if this, when you click the graphing tool, if it goes through all of the points that you plotted, that's just like a confirmation that you did it correctly. Does that make sense? So I would do that. Okay, so I have my 2 x-intercepts, and then I can still see the y-intercept. It was 0, 15. Oh, it won't let me plot that one. That's okay. It's only going to let you plot what you can see on the axes, so that's fine. It just means I won't be able to see it crossing the y-axis. But I do have enough points, so I plotted my points, and now I'm going to click the parabola tool, and I'm going to follow the directions that the red writing is giving me. So it says place the vertex. So my vertex is down here. Choose how the curve opens. So we already agreed that it opens up, so I can click anywhere above. Then it says plot another point. So you can pick one of these 2. And do you see how it makes a curve that goes through all of the points that I plotted, even though I only had to place one other point besides the vertex? That's just a confirmation that I did it correctly. So we'll click check for that one. Okay, determine the axis of symmetry. So remember, axis of symmetry is a line. So this will be wrong if you just put it in as a number. You have to have x equals for the axis of symmetry. So it's going to be x equals h, or the x value of the vertex. So that was what, 3? Okay, so x equals 3. All right, and then you can look at the graph at this point and tell me, does it have a maximum or a minimum?
Yeah.
It has a minimum, definitely. So I'll select minimum. Okay, and the minimum value is just the y value of the vertex, which in this case was -12. Okay, and then domain and range. What is the domain of every quadratic ever? That's right, all real numbers, aka -infinity to +infinity. And we know that our infinities always have parentheses, so -infinity to +infinity. All right, and then the range is going to be based on the direction, right? So since our parabola is going upward, we know we're going to go to +infinity, and we're going to start at our minimum. So we would want to bracket on the -12, the minimum, because we do actually hit that point, but then it goes up to infinity. Okay, so take a good look at that. Can I field any questions on that? Is that helpful? Also feel like sometimes it's just helpful to see somebody put all of this stuff in, especially with the graphing tool. Yeah.
So there's like different kinds of parabolas, like the way they're laid out. Like some don't have like they won't have like yeah, there's like the just the -12 thing. Like sometimes they won't have that, or sometimes they won't have like the power, like they have like the 3.
So they can be in standard form,
yeah,
and not just in vertex
and
form.
even,
Yeah.
So you didn't send them like one like this on a test. Would this one be like the most similar to the structure of it?
If I do it in class, you should study it for the test. So the question was, is this one most similar to the one on the test? If I do it in class, you should study it for the test. Let's see what the next one is. because I had this one written down too. So I would say it could be like 1 or 2. But remember, anything on the review is fair game for the test. But yes, you can make connections like that. I just probably can't necessarily say them. But yes, if I do it in class, you should study it for the test. And yes, there is only one long one on the test. You just take that information as you will. So let's do 2 though. Let's have one more practice of the long one because, you know, the more the better. Okay, so determine whether the graph of the parabola opens upward or downward. I am just going to write it so, because it'll, as I scroll, it'll come with me if I write it. M of x equals negative 1/3 times x plus 1 squared plus 1. Okay. So does that parabola open upward or downward?
Downward.
Yeah. And how do you know, by the way? Because we didn't talk about that.
Negative.
A is negative. Good. So vertex is h comma k. Change the sign of h, keep the sign of k. So what is your vertex?
Negative 1.
Negative 1, 1. Easy enough. Okay. No, I hate that it like pops back up to the top every time you answer one. It drives me bananas. Okay, determine the x-intercepts. I'm going to come do that up here. So x-intercepts are where we set y equal to 0 or set the function equal to 0. So we have negative 1/3 times x plus 1 squared plus 1 is equal to 0. So negative 1/3 times x plus 1 squared equals negative 1. Okay, and how would we get rid of a negative 1/3? Multiply by 3. Good, and I'm going to multiply by negative 3 so that I also cancel out that negative. Okay, so negative 3 times negative 1/3 cancels or becomes 1. And so we just have x plus 1 squared equals, and then negative 1 times negative 3 is 3. So now I'm at the place where I can take the square root of both sides. So the square root and the square cancel. So x plus 1 equals plus or minus the square root of 3. And don't forget your plus or minus when we take the square root of both sides. So obviously, unlike the last one where the square root of 4 was 2, I don't know what square root of 3 is, so could be that, could not be. Let's see. Let's subtract 1 from both sides. X equals negative 1 plus or minus the square root of 3. Okay, how we doing? Good? It's tougher because, like I said, you might have a square root, might not. Could be perfect square, could not be. But, I mean, it's not going to make you simplify it further than that, so that's pretty convenient. So it looks like there's 2 x-intercepts. First one is negative 1 minus the square root of 3, comma, 0. And the second one is negative 1 plus the square root of 3, comma, 0. Okay, x-intercepts are done. How we doing? Good. Next up is y-intercept. So we know that y-intercepts are found when we let x equal 0. So y equals negative 1/3 times 0 plus 1 squared plus 1. So let's see. 0 plus 1 is 1. 1 squared is 1. Okay, and negative 1/3 times 1 is negative 1/3. Bring down the plus 1. So you can put this in your calculator. Okay, remember we talked about this in class. You would do like, there's a couple different ways you can do it. I would do negative 1 and then the little fraction symbol and 3 and then plus 1, and then change it to an improper fraction. But what do you get? Yeah. Okay, so y equals 2/3 or 0,2/3. There you go. Okay, so time to put all of this stuff on a graph. So like I said, you can try to click these points if you want, but I wouldn't. I like to plot them. So what was my vertex? -1, 1. Okay. Now sometimes it will let you put in like the square root ones, like the -1 minus √3 and the -1 plus √3. But the way you know whether it's going to do that or not is by whether the square root symbol shows up in this box right here. So it's not there, which means it's not going to let me type that in. So I'm not even going to worry about trying to type my x-intercepts, but that's okay because as long as I have the vertex and one other point, it will let me graph it. And I do have the vertex and one other point because -1, 1 was the vertex. And then what was the y-intercept? 0, 2/3. Okay. So 0, 2/3. As long as I have the vertex and one other point, it will be fine. But they may let you put the x-intercepts in like the square root form, but the way you know is the tool would be there. Since it's not there, I know that I can't put them in. Does that make sense? Did I see a question in the back?
No,
I noticed. Yeah. So if it's there, you can do it. If it's not, you can't. But it's still enough information. Now we would click the parabola tool. We place the vertex, so we know that's the -1, 1 point. And then it says choose how the graph opens. We know it opens down, so you can click anywhere down. And then you click on the second point, and there you go. Okay, axis of symmetry, we have to have the x equals. So x equals the x value of the vertex. So it would be x equals -1. And then does this one have a maximum or a minimum? Maximum, good. Yep, and what is that maximum value? 1, very good. Okay, and what is the domain of every parabola? Yep, -infinity, excuse me, to infinity. And then this one is facing down. So it's not going to be the minimum to infinity. It's going to start with -infinity. So parenthesis, -infinity. And it's going to go to the maximum, which is 1. But it actually hits the maximum, so that 1 gets a bracket. So the range would be -infinity to 1. So the domain, nobody better miss that on the test. I'm coming for you if you miss it. But the range, remember, it's dependent on whether it's up or down. So if it's up, it's the bottom number to infinity. If it's down, it's -infinity to the top number. Okay, all good? All right. So there's 2 examples of the hard ones. Picked out a couple more. Let's see. Let's do. Let's do this one because I feel like people do it wrong a lot. This is number 11 from your review. So this says m plus 3 times m minus 4 equals -10. So I can just say m plus 3 equals -10 and m minus 4 equals -10, right? Yeah? No. What is that? What I'm trying to do, what is it called? The what? Zero product property, because you are only allowed to separate factors like that when it's set equal to 0. Okay, so let's do some multiplication. We have a binomial times a binomial, so we'll FOIL. M times m is m squared. M times -4 is -4m. 3 times m is 3m. 3 times -4 is -12, and that's equal to -10. So reducing that, m squared minus m, or minus 1m, minus 12 equals -10. What would be my next step, though? Yep. Add 10 to both sides. So that would give me m squared minus m plus 2. No, minus 2. Minus 2 is equal to 0. So that factors into m minus 2 times m plus 1, because -2 times 1 would give me -2. -2 plus 1 would give me the -1 in the middle. So what are my two values of m? -1 and 2. Yep. And so it just says, if there is more than one solution, separate with commas. They've already got those curly braces for me, so -1 and 2. Any questions? Go ahead, you're good. Any other questions? Okay, y'all are awfully quiet today. Let's see what else I picked out to do with you. Let's do 30. Not sure what it is, but I wrote it down. Okay, so you could have one like this too. This would be another example of one you could have that will have to do with graphing it or sketching the function. So h of x is equal to x, skipping my 1/7. 1/7 times x minus 4 times x plus 2 times x plus 5. So just writing it down to get familiar with it, I think that's important. But the first thing they're asking me about is end behavior, which when it's in standard form, meaning it's all multiplied out, that's pretty easy. But to discuss the end behavior when it's in factored form like this, I'm going to have to do a little work. So what is the leading coefficient? What do you think it is? 1/7, yeah. So the leading coefficient, or the number on the front, would technically be 1/7 times 1 times 1 times 1. So you do get 1/7. If you're wondering where the ones come from, it's the numbers that are in here. But it's 1/7 regardless. And so then the degree, when it's in factored form, we have to add the powers on the factors. So 1 plus 1 plus 1, 1 plus 1 plus 1, that's 3, which would make our leading term, which is what we would normally look at in standard form, 1/7 x to the third. Point is, though, that's a positive leading coefficient with an odd degree. So positive odd means you're down on the left and up on the right. I remember it by the picture, and then if I draw it, I can fill in the blanks correctly. So part 1 says the end behavior of the function is down to the left and up to the right. Okay, any questions on how I got the leading coefficient, the degree, brought them together to get the leading term, and then determine the end behavior? Floor is yours. Everybody good? Which part?
Since it's a fraction, it's odd. It's positive.
Just because there's not a negative in front of it. There would be, it would have to be a negative in front of it, that's all.
So do we need to memorize, or there's a way to look at it?
You'll have to memorize the, which is which. So the part you'll need to memorize. So we'll pause on this and come back.
Okay.
The part of this that you'll need to memorize is you'll need to know that a positive leading coefficient with an odd degree is down on the left, up on the right. A negative leading coefficient with an odd degree is up on the left, down on the right. So there's 4 of them, 4 cases, if you will. Third one would be positive leading coefficient with an even degree is up and up. And then a positive leading I'm sorry, we just did that one. Negative leading coefficient with an even degree would be down and down. So memorization wise, you will have to know these 4 cases for your test. So I calculated what the leading term would be because the leading term told me about the leading coefficient and the degree. So since I had a positive leading coefficient, positive 1/7, and an odd degree, which was 3, I knew I was down on the left, up on the right.
So the degrees are the exponents?
Yes, the degree comes from the exponent. So remember, if it's in standard form, meaning everything's multiplied out, it's just the highest power. But in factored form, you have to add the exponents together. So that's why we did 1 + 1 + 1 for this one.
And the ones, were we still on number 30?
Yes,
Okay, so this one was in factored form, so we're adding the exponents.
to get the degree.
Okay.
Mm-hmm. Yep, so you're adding the exponents to get the degree in factored form. So 1 + 1 + 1. Oh, yeah, absolutely. I clicked off of it pretty quickly. There you go.
And then if it's in standard form, you take the highest?
Mm-hmm. Yep. And standard just means they multiplied it out. Nothing fancy. So it would just be like a term plus a term plus a term plus a term, not like multiplied. When all the factors are multiplied, that's factored form. Does that make sense? Yeah. Yeah, question. Like we did in 1 and 2, but I can't emphasize this enough. Anything on the review is fair game on the test. So every single, I mapped it out. I can tell you number 1 on the test is this question on the review. Number 2 on the test is this question on the review. So if it's on the review, it's fair game on the test. So if you have to graph them on the review, fair game on the test. Mm-hmm.
So like when you did 1/7 times 1 times 1 times 1, was that because the power was 1 or because
The coefficient was 1, the number on X. So the reason that I did, wait, where'd it go? Here it is. 1/7 times 1 times 1 times 1, that was these blue ones here. And I just wrote it like that because if it were something else, like a 2, like let's say that these 2 were 1s, but this one was a 2. You would have done 1/7 times 1 times 1 times 2. You have to basically, to get the leading coefficient, you have to multiply all of those front numbers together.
And then the degree is all the powers
Added together. Mm-hmm. Unless it's in standard form, which means they already multiplied it out, then it would just be the highest power. Yeah. Okay, any other questions? Okay, so all we've done so far on 30 is answer that the end behavior is down on the left and up on the right. So we've still got parts 2, 3, and 4. So find the y-intercept. We've been doing this a bunch. We know how to find the y-intercept. So the y-intercept is where we let x = 0. So that would be 1/7 times 0 minus 4 times 0 plus 2 times 0 plus 5. So it would be 1/7 times -4 times 2 times 5. And you change that back into a fraction, but you get -40/7, or at least I did. Somebody check me on that. Yeah, okay, but this is our y-intercept where x = 0. So our coordinate point would be 0, -40/7.
And that's 0 plus 2, right?
Yeah, sorry, it didn't come out very well. There we go. Yeah. So 0, comma, negative 40 over 7. Are y'all good with that? So what else is it asking us for? Okay, real zeros. Give me, so this is review, just kind of coming back to here. Give me 3 names for zeros, including zeros. So give me 2 more. Zeros, x-intercepts, and roots. So if they say zeros or x-intercepts or roots, all 3 of those directions are telling you to do the same thing. Okay, for all 3 of these, you're going to set the function equal to 0 and solve. So for all 3 of those, you're going to set the function equal to 0 and solve. Doesn't matter what they ask for. So I think in this one, they asked for zeros, but again, we do the same thing every time. Oops, I want this. Okay. I can have a ton of room to do it here, but that's okay. I'll do it up here where I can see the function. So negative 1/7 times x minus 4 times x plus 2 times x plus 5 is equal to 0. And you just set each factor equal to 0. These are so much easier in factored form. Obviously, you don't need to set the 1/7 equal to 0. Oops, it's a positive 1/7, not a negative. You don't need to set that equal to 0 because that's no solution. We don't ever set the standalone number or leading coefficient equal to 0. But we would have x minus 4 equals 0, x plus 2 equals 0, and x plus 5 equals 0. So x equals 4, x equals negative 2, and x equals negative 5. So 4, negative 2, and negative 5. And how does it ask us to list them? It says just to separate with commas. So we're not writing them as an ordered pair like we did with the y-intercept. We're just separating them with commas. So negative 5, comma, negative 2, comma, 4. Okay, any questions about those 3 parts? Okay, so this one does ask you to graph. So, you know, I know y'all were asking me some questions like, will it be exactly like this one? Like, I can pick some problems to do with you in class, but y'all, I can't get that specific. Like, you already have a review that every single question comes from the review. If I choose to do it in class, hint, hint, yes, you should study it. But like, other than that, don't read too much into it. You know what I mean? Like, I'm doing 2 in class that have graphs in it. So likely you're going to have 2 graphs on the test. You know what I mean? Yes, you can read into it in that way. But like, other than that, there's not much more specifics I can tell you. Every question comes from the 50 questions that are posted in ALEKS. And if I do it, or if I choose to do it, you should probably study it. That's about the best I can do. So like this one is graphing as well. It's just not a 9-part graphing problem. It's a 4-part. So I'm still going to plot out all of these points. Okay. And it does say I need 4 points, which this is convenient because I have 4. There's 3 here and 1 here. So again, I'm going to use this tool because I just like it better. So I'll do my y-intercept first. 0, comma, negative 40 over 7. Okay. Then the rest of them were x-intercepts. So it's going to be like negative 5, 0. Plot that point. Negative 2, 0. Plot that point. And 4, 0. Plot that point. So I've got 4 points, which the directions said I had to plot at least 4 points. And then from there, I just click graph a function. That's it. So utilize that plot a point tool as much as you possibly can, for sure. Okay, any other questions? Yeah.
Work or something out, like if we weren't getting all 4 points, like if we had to find like another
Uh-huh.
point, could you like show us?
So how do we find other points if we had to? Using what?
It's like the exercise.
XY chart. So if like this one was convenient, like you said, because it asked for 4 points and we had 4 points, but not all of them are like that. Some of them require 5 points and some of them require 6. So let's just pretend for a minute. I think that's a great question because it could ask for whatever. Let's just pretend for a minute it was the exact same problem, but it asked for 6 points. So I needed 2 more. I only had 5 within the information that I found. So what I would do from there is a little XY chart. And basically you just pick your X's and you plug your Y's, or you plug it in to get your Y's. But you do want to be smart about what X's you choose. So like, here's what I would do if I were you. We already know X is -5, like we already know what it is at X -5. We already have a point at X -2. We also have a point at X0, it's -6, right? And we have a point at X4. I would pick some in between here. You see what I'm saying? Like, don't pick something wacko. Like you are picking your X's, but make an educated guess, like be smart about your pick. So if this is what I had so far, see my X-intercepts here? If that's what I had so far, I think what I would do is pick something in between my lowest one and my highest one. So I would probably do the easiest thing I could think of, which would be like 1 and 2. Does that make sense? And so we'll put 1 and 2 here. And then to get them, you would just plug it back into the original function, which of course I can't see. So the original function is, I'm going to write it so it comes down with me. H of X equals 1/7 times X minus 4 times X plus 2 times X plus 5. So I would really just do it in my calculator. H of 1 would be 1/7 times 1 minus 4 times 1 plus 2 times 1 plus 5. And you actually can type that exactly in your calculator. You would just need to put the 1/7 in a set of parentheses. I would probably do the subtraction and addition first. So like this is -3, this is 3, and this is 6. So that's what I would put in my calculator. I would say 1/7 times -3 times 3 times 6. Oh man, I typed it wrong. Okay, and then you change it back to a fraction, you get -54/7. And I know your initial thought is, oops, I said 54/7 and wrote 57/7. 54. Did anybody else type that in and get the same thing? 54/7? Yes, okay, I got some nods in the back. Anyway, you remember, you don't actually plot that point. You just click the plot a point tool and you type in 1 and -54/7 and it plots it for you. But there's 1, and then you would do the same thing with 2. You would calculate H of 2, which I'm not going to write it out. I'll just plug it in. 1/7 times, and if I'm just plugging it in, I'm going to type the whole thing. So open parentheses 2 minus 4, close parentheses, open parentheses 2 plus 2, close parentheses, open parentheses 2 plus, not divided by, 2 plus 5. And you get -8 for that one. So that's kind of convenient. But also, can you see that on the graph? You see, like, so let's talk about a couple of different reasons why we would do this. One is definitely to get extra points if they needed more than what you had already found. Okay. But second, if you just had extra time and you were going back to check your answers, You could find extra points to make sure your graph goes through those extra points like I did here, but anytime you need extra points, just do an XY chart, but do be smart about what X values you choose. I would pick X values that are somewhere between your lowest and highest X values on the graph. So in this case, that would be something between probably -5 and 4, but choosing the easiest numbers possible. So I did 1 and 2. Does that help? That was a good question because it can fluctuate. Sometimes it says plot at least 5. The most I've seen is 6. Is that consistent with what y'all have seen? It's either 4, 5, or 6, but hopefully you won't have to find any extra ones because that would be the most convenient thing. Okay, that was a really good question. Let's also look at 21. Okay, this one should be super simple. All right, so it says find a polynomial f of x of degree 3 that has the following zeros. So remember, zeros, roots, and x-intercepts are all the same thing. So if they're telling you that the zeros are 2, 6, and -1, that's the same thing as telling you, bless you, that the x-intercepts are 2, 6, and -1. So x equals 2, x equals 6, and x equals -1. And we have to figure out the factors from that. So what would x equals 2 have come from? X minus 2. That's right. And remember, you're basically setting it equal to 0 to get the factor. So you could subtract 2 from both sides and you would have x minus 2 equals 0. So that's how you can say that x equals 2 comes from a factor of x minus 2. So using the same logic, x equals 6 comes from a factor of what? Yeah. And what does x equals -1 come from? Yeah. If you get one like that, please don't miss that. So x minus 2 times x minus 6 times x plus 1.
So what if it has a multiplicity on it?
Okay, good question, because sometimes they do. So the question was, what if it throws me one? Because y'all know these are different iterations, right? Like that's how it works,
Like on the review here, mine
Says,
multiplicity on it.
yes. Okay, I'm glad you asked that. Can you tell me what yours says?
-8 multiplicity 2, comma 2 is of degree 3.
Okay. Okay, so what if they gave you that instead? So they didn't give you 3 distinct ones. So remember, the multiplicity represents the power on the factor. So since they didn't give me any multiplicities in the one that I just worked in the review, excuse me, I assume that all the powers are 1, which is why I just kind of wrote the 3 factors together. But if it's a multiplicity of 2, that's just the power. So it would still be considering like x equals -8 and x equals 2. So you would still ask yourself the same question, like where did a factor of x equals -8 come from? Would have come from a factor of x plus 8. And where did the x-intercept x equal +2? I'm almost giving the answer. +2 come from x minus 2. But since the 2 didn't have a multiplicity written, we assume it's multiplicity 1. So your function, they would give you the f of x part, would just be x plus 8 squared and x minus 2. Yeah, great question, because it could totally throw you one like that with multiplicity, but it just becomes the power on the factor. Does that make sense to everybody? Okay. And I think I picked one more type to go over with you. I am going to do both types. You could potentially have either one, but there is one like this on the test, and I want to make sure I go over it with you. Does anybody remember what we do for ones like these? U sub. Yeah. So let's write it out. We have 4 p to the 2/3 plus 13p to the 1/3 minus 12 equals 0. So when you see this, you are going to do u sub. Okay, u is equal to, I'm going to write out some notes for you for study purposes, then we'll actually work it. Okay, u is equal to the variable and power in the middle, and u squared is equal to the variable and power in the front. So for our specific case, that would mean that u is p to the 1/3 and u squared is p to the 2/3. Y'all following me so far? Okay, so going back to here, that would mean that 4u squared plus 13u minus 12 is equal to 0. All right, so let's see if we can factor this. Yeah, we could do 1 and 12. What else could we do? Throw me some other stuff. We could, for the front one, we could only do 4u and u or 2u and 2u. I'll try 2u and 2u. Okay, what about 12? I could do 3 and 4. What else could I do?
2 and 6.
2 and 6 or 1 and 12, right? Okay, remember how I always say educated guess, not random guess? All right, so here's the thing. You told me that my options were 6 and 2, 3 and 4, or 1 and 12. Everybody agree with that? So one of the educated guess parts is that I know within the factors, I can't have any common terms. So you see how right now I have a 2u and a 2u? Well, I can't put a 4, a 6, or a 12 because they would have a common factor of 2. 2 and 12, 2 and 4, 2 and 6. So I can't do that. So educated guess, I'm going to erase this and I'm going to try the other option, which is 4u and u. Okay, let's see. I think I'm going to try putting a 4 here and a 3 here. And for the same reason that I can't have a common factor, that's why I chose not to put the 4 here. So this is what I'm thinking. Now talk to me about my signs. If I need 3 and 4 to multiply to give me a negative 12, then one has to be negative, the other one has to be positive. Any thoughts?
+4 minus.
I think so, yes. That's my educated guess, +4 and -3. So there is my educated guess of what I think the factors are. But I can go on the side and multiply it back out to prove that I got the correct factors. So 4u squared plus 16u minus 3u minus 12 equals 0. Yep. 4u squared plus 13u minus 12 equals 0. Okay, so u equals 3/4, right? And u equals 4. So do I just put that in? Am I done? Because this is u substitution. So I have to do the back substitution step. What was u originally equal to? 1, the p to the 1/3, right. So what I really have is p to the 1/3 equals 3/4. And also p to the 1/3 is equal to -4. But we know that the 1/3 power is the same thing as the cube root. So this is actually the cube root of p equals 3/4, and the cubed root of p equals -4. And now I have to get rid of the cubed root. So how do I do that? Cube it. You get rid of the square root by squaring it, so you get rid of the cube root by cubing it. Okay, so the cube and the cube root cancel. So we get P equals, now when you raise a power, when you raise a fraction to a power, you just do the top and bottom. So 3 raised to the third power is 27. And 4 raised to the third power is 64. And that does not reduce. And then we would have -4 raised to the third power, which is -64. So those would be my 2. Okay, that one's kind of tough, which is why I wanted to make sure I went over it with you. Any questions? I want to show you another one like it, okay? Another possible U substitution one. This one's very similar, okay? We're going to work it the same way, but there's going to be one thing that's different, and it's that we're dealing with square roots here instead of cubed roots. So you're going to see what that works out to be. But let's work another one, because this is a fantastic example of something else you could get. So y to the 1/2 minus 6y to the 1/4 minus 16 equals 0. So it's still a U sub 1. Okay. U is still the variable in power in the middle, so y to the 1/4, and U squared is the variable in power in the front, y to the 1/2. So that gives me U squared minus 6U minus 16 equals 0. Okay, so that one's a little easier to factor because the A term is 1. So what would I use from 16 that would add to give me -6? Yep. U minus 8, U plus 2. So I get U equals 8 and U equals -2. So far the processes are identical, right? We haven't really done anything different up to this point. It's in the back substitution step that things are going to get a little different. So we're at the back substitution step. U was originally equal to y to the 1/4. So it's not U equals 8, it's y to the 1/4 equals 8. And it's not U equals -2, it's y to the 1/4 equals -2. Y'all still with me? Now, up to this point, it's still the same. Then last time I had a 1/3 power, this time I have a 1/4 power, but nothing is changing. The 1/3 power was the same thing as the cubed root. In this problem, the 1/4 power is the same thing as the 4th root. So y to the 1/4 equals 8 is the same thing as the 4th root of y equals 8. And y to the 1/4 equals -2 is the same thing as the 4th root of y equals -2. This is where it's different. This is where it matters. Okay, so last time we had cube root, so we cubed both sides. This time we have 4th root, so we'll raise both sides to the 4th power. So far, pretty normal. Okay, so 8 raised to the 4th power is 4,096. So y equals 4096. Okay, this is where it's different. I'm doing this on purpose to point it out. You cannot have an even root equal to a negative. That gives you no solution. And an easy way to think about that is it's because you can't take the square root or the even root of a negative. Okay, but if you have an even root equal to a negative, you have to throw out that piece. Last time it was a cubed root equal to a negative, so we were allowed to keep it, cube both sides, and move on. But you cannot have an even root. So square root, 4th root, 6th root, 8th root. You're not going to have any that high, but that's the point. You cannot have an even root set to a negative. So I have to throw that piece out, which means my only answer is 4096. Does that make sense? I wanted you to see the difference because you could get either one of those. Okay, so
Have an even root that's
equal to a negative.
equal to.
Yeah, so no even roots equal to a negative. I wish it would save my work so I, like when I write, so I could go back to 40 and show you, but that's why it was okay. What did we get last time? The fourth, it was like the cubed root of y equals -4. Is that what it was? Right. So I could keep that one because it was an odd root equal to a negative. But I can't have an even root equal to a negative. So I had to throw this one out, which gave me only one answer. Whereas with this one, I got 2. Does that make sense? Okay. Do you guys have any from here that you want me to work? All right. Did everybody sign the roll? Has everybody signed up for their test? Okay. So I'm going to say this one more time. Every single question from the test comes from the review. Nothing outside of the review is on the test. If it's on the test, it's on the review. I have a whole chart. Okay. So anything on the review is fair game. But if I did it in class, I highly recommend studying it for the test. You take that as you want to take that. All right. Good luck.
You're so funny.